Hi Year 12s, we're going to be solving some more trig equations today, moving on to ones involving identities that we did last lesson. You'll find the properly written out examples attached to the assignment. Okay? Right, so if we're going to solve this equation here, we want to get the trig function cos theta on its own, so we're going to square root. Remember, you have positive and negative. Okay, so let's think about that. If we, on our calculator, inverse cos of 2/3, see what we get, 48.2 degrees. And that gives us our acute angle to put in our cast or diagram or graph. So, as you know, I'm a massive fan of cast. Right, now here, cos is both positive and negative, so actually we're going to put a stick in all 4 quadrants. Okay, so, and that stick is going to make an angle of 48.2 with the x-axis. Okay, so I'm going to just store that on my calculator. Right then, we're going to whirl around going from 0 up to 360. So our first one is 48.2, and then we keep going and we'll get to 180 minus that answer. So we get 131 as well. It's to 1 decimal place, this question. Okay, and then the next one, we're going to get round to 180 plus 48.2. So that's 228.2. And then finally, we're going to get all the way around to 360, minus 48.2. So our final answer is 311.8 degrees. Okay. Right. Now, a familiar sort of question that pops up is a hidden quadratic. Okay, we can see we haven't just got sine squared, we've also got sine. So we have a hidden quadratic. If it makes you feel better, you could set up a substitution. Y is sine x, and then you'd be writing 3y squared minus 5y plus 1 is 0, and then you can solve that on your calculator. If it's show detailed reasoning, you would have to then make up the factors. Okay, so we have a polynomial degree 2 with coefficients 3, -5 and 1. Okay, it's not very pretty, so for that one, rather than factorising, you would have had to complete the square or use the formula. Okay, so we've got, if you're using this substitution, we end up with y is 5 plus or minus root 13 over 6. Or you can just jump straight to this black version here. We've got sine x is 5 minus root 13 over 6, or sine x is 5 plus root 13 over 6. And I'm just going to check these are sensible values. Now we can see that the addition one is greater than 1, so we can't have any values of x for which that works, because sine goes between -1 and 1. So we write no solutions. Not no real solutions, just no solutions at all. Okay? However, with the subtraction we get a nice sensible positive 0.2324. Okay, right. So I'm going to draw my cast diagram for this question. Okay, I know this gives us a positive value, so sine is positive in these 2 quadrants here. We always make the angle, it's going to be with the x-axis. Okay. Right, so first we need to do inverse sine, don't we? So x is going to be inverse sine of, and then we had 5 minus root 13 over 6. So that gives us 13.4 degrees. I stored that on my calculator, so hopefully I don't make too many mistakes. And then we want to find all of the solutions in the range 0 up to 360. So we've already got our 13.4 degrees there, okay, but if we whirl around, we want to do 180 minus 13.4 degrees. Okay, 166.6 degrees, and that will be it, because we can get around to 360 and not hit any more. So this is fine for the working out. You don't have to have the red bit. If it says show detailed reasoning, okay, then you would need to do some work to show how you solved your quadratic. But from there on in, you don't need to write inverse sine, okay, and you don't need to write a calculation for the 166.6 if you have your diagram nice and clear, whether it's a cast diagram or a graph. Okay, so we're going to get slightly more exciting now. I think there's a question a bit like this in exercise 10G possibly. Okay, so this time our equation, we've got our range of values. Our equation here has got both sine and cos in it. And it looks like you could divide both sides by sine. But if you do that, you've lost a variable. Okay, so we don't want to do that. Instead, we're going to move everything to one side and factorise. So let's do that. 3 sine x cos x minus 2 sine x is 0. So we can take sine x out as a common factor. Okay, right. Now this means that one of our solutions is when sine x is 0. Okay. Right, now sine x is 0. I am going to draw the graph, shock horror for this, from minus 180 up to 180. Okay. Right, so we can see that sine is 0 at negative 180, 0 and 180. So this gives us x is plus or minus 180 and 0. Okay, let's look at the other bracket. So we've got 3 cos x minus 2 is 0, which means that cos x would be positive 2/3. Now we've already solved this one, haven't we? So if I just scroll back up again, I'm sure we did shift inverse cos of 2/3. Yeah, there we go, 48.2. All right, for this one we want our cast diagram or your graph of cos. Okay, cos is only positive this time, so we're only looking in these two quadrants. So we draw our sticks in those two quadrants, and the angle made is 48.2 degrees. Okay, and if we're going from negative 180 all the way to 180, then we have simply got negative 48.2 and positive 48.2. Okay, so the full set of solutions is x is plus or minus 180, 0, and plus or minus 48.2 degrees. Okay, so we still haven't needed, even though we've got sines and coses there, we haven't needed to use any identities. Okay, this one, you need to watch out. If it looks like you can divide by one of the terms, if there's a common factor, move it to one side and factorise. Okay, right, this one here is a bit of a change because we have sine and sine squared, so we're thinking hidden quadratic, but we also have cos squared. Okay, now if you have a sine squared and a cos squared, then you know you can use your identity from the other day. So our identity was sine squared theta plus cos squared theta is equivalent to 1 from Pythagoras, which means we could write cos squared theta in terms of sine squared theta. Then we're happy because we've got this sine x here that we can't mess with, so we need a quadratic in terms of sine. So if you're trying to decide which one to go for, look for the term that doesn't have the squared, and that's the one to go for. Okay, so let's replace 2 cos squared x. So we've got 2 times 1 minus sine squared x plus 9 sine x, and I'm going to move everything across. Oh no, I'll just put equals 3 sine squared x at the minute because I think it'll go the other way. Expanding out. Moving everything to one side. Okay, and then we have our quadratic. So you can write a substitution if you want to. I'm usually too lazy. Okay, so let's see what we get. Our coefficients are 5, -9 and -2. Ah, lovely. So we've got -1/5 and 2 as our values. So I'm going to pretend that I had to show my working out. So I'm going to have 5 sine x plus 1 and sine x minus 2 are my values. Let me just check. Yeah, I've got that the right way around. Okay, so that means either sine x is -1/5, now that's going to be fine, or sine x is equal to 2. Hopefully your alarm bells are ringing there. We don't get any solutions since sine x must be between -1 and 1. Okay, right, so let's focus on this one here. If I do inverse sine on the calculator, okay, we get -11.5 degrees. So I'll store that. Okay. And I'm going to draw my cast diagram. And I'm going to look at where sine is this time negative. So sine's positive in all and the s for sine, so it's negative here and here. And we already have the -11.5 degrees in there. We draw a stick in this box, make the angle with the x-axis 11.5 degrees. Okay, so then we do some whirling around. We've already got -11.5, so we also go from 0, the positive x-axis, to our angle. So that's going to be -180 plus 11.5. So we get -168.5 degrees. Okay, and that has then covered the full range of values, so we're finished. So it's all the same, we just had to apply an identity at the beginning. For the next example, we've got something that looks like a hidden quadratic, but the trig functions don't match. And we need to make them match. We're going to write them all in terms of cos, because that is the one without the squared in it. So let's just think, we've got sine and we want it in terms of cos. And using our identity, so sine squared theta plus cos squared theta is equivalent to 1. So that means if we've got sine squared theta, we can do 1 minus cos squared theta to write it in terms of cos. Okay, so let's pop that in here. So we put it in brackets. And then we do expanding and tidying up. Okay, and then we set it all equal to 0 because we now have a hidden quadratic. I'm going to move everything to the right so I end up with a positive cos squared. Okay, and then we get the calculator again. Okay, so we've got plus or minus 3 plus or minus root 17. Okay, now the calculator shows us that 3 plus root 17 is greater than 1. So there's no solutions. Okay, whereas the other one is negative 0.28, so that one's okay. So we can use our calculator to find what we get when we do inverse cos. So we get 106.3 degrees. Okay, and we can draw a cast diagram. Now this time cos is negative. So cos is positive where there's a C and an all. So that means cos is negative here and here. And that ties in with the angle we've got. It's made, so we always measure from the positive x-axis, so this angle is 106.3. So by symmetry, the other stick is going in here, and this will be also 106.3. Okay, right, we want to find all the angles in the range negative 180 to 180, so that's nice and easy. We just get plus or minus 106.3. Okay. Right, this time we don't have any squared terms, okay, and we don't have any sine or cos to factorise. So we're going to use the other identity, okay, and if we remember, that was that tan theta is sine theta over cos theta. We can't solve this equation at the minute because it isn't in terms of a single trig function. It's okay if we've got brackets multiplying to make 0 with a single trig function in each, but here we can't do that. Okay, so we need to do something. So what we're going to do is to convert things into tan by dividing everything by cos theta. Okay, so we've got over cos theta, over cos theta, over cos theta. So every term is divided by cos theta. So what does that give us? Well, sine theta over cos theta is tan theta. Cos over cos is 1, so we just get root 3. And 0 divided by anything is 0. So there we go. Much easier, isn't it? Minus root 3. So I should know that one. That's the standard one, isn't it? Inverse tan of negative root 3. It's minus 60 degrees. Okay, now this time our inequality is between minus 360 and 360. So let's draw our cast diagram. We've got a negative value for tan, so we're not looking at where t and all are, we're looking in the other quadrants. Okay, and we've already got, for this stick, we know that's minus 60 degrees. So our other stick goes here, and our angle made with the x-axis is also 60 degrees. Right, so now we do some whirling around. So let's go all the way around to minus 360, that'll be there. So going back, the smallest value, the lowest value we encounter is this one. So it's going to be minus 180 plus, sorry, minus another 60. Okay, so that's going to be, let me just think, 240, minus 240. Okay, and then we've got our minus 60, which we've already got. And now we go in the positive direction. The first one we encounter is here, so that's going to be 180 take away 60, so that's going to be 120. Okay, and then finally we go all the way around till we're nearly at 360, but take away the 60, so we get 300 degrees. Okay, So that's all of our 4 solutions. Again, with all of these, remember you can check them on your calculator using solve_n or the graph. Right, again, we've got something with sine and tan, which makes things a little bit trickier, okay? And in fact, this time, we're going to kind of do the opposite. So whenever you see a tan and another trig function, you can replace the tan with sine over cos. Okay, now because it's tan 2x, it's sine 2x over cos 2x. Okay, now then, we have a fraction. We don't like fractions when we're solving, so we're going to multiply through by cos 2x. So we've got 4 sine 2x cos 2x is equal to sine 2x. Now this is like the earlier one we did, where I warned you not to divide by sine 2x. So what we're going to do is move it to one side and factorise. Okay, and now we can solve. So we've got sine 2x is 0, and if you remember, this time it's a bit, we're going to need to think about our limits here, okay? If we remember about the sine graph, it's going to cross the x-axis at 3 different places here, because instead of working with x, we're working with 2x, so we need to change our range of values. So we're going to double everything. So we're interested in going all the way to 360 degrees. Now that will give us that 2x is equal to 0 or 180 or 360. Okay, we found all of the values first, so now we halve them, so that they're in the original range. Okay, our other option was 4 cos 2x minus 1 is 0, so cos 2x would equal 1/4. That's positive quantity. So let's do a cast diagram. So we don't bother doing cast if we've got like 0, 1 or minus 1, because it's on like the lines, so it's really hard to tell. Okay, right, cos is positive in these 2 quadrants. We'll put our sticks there. Okay, and then we'll do inverse cos of 1/4. Okay, so that will give us 75.5 degrees. Now we want all of the solutions for 2x between 0 and 360. So we're starting with 2x is 75.5 degrees. And the other one, if we whirl around, from 0, there we go, we get 360 minus that. So 284.5. Okay, and then we can halve our answers once we've got them. Okay, so we've got 5 solutions for that question. Okay, so this one we have a sine and a cos, we can't factorise. What do? We're going to use tan x is sine x over cos x. I think that should be 360. Okay, so we divide every term by cos x. Okay, and so that means on the left we've got tan x and on the right we've got 2. Now remember, that's fine for tan. Tan is not limited to be between -1 and 1. So let's do inverse tan of 2, and we get 63.4 degrees Okay, we're going from 0 to 360, so we have our cast diagram. We look for where is tan positive. So tan is positive in the all and the tan section. We draw our sticks in there. Okay, and so we can see, hopefully, if you're whirling around from 0, you get your 63.4, and the next one will be 180 plus 63.4, which is 243.4. Okay. Right. So this last one, this is a classic format of a question where you start by, we have to prove this identity, and then after that we're going to solve something based on that. Okay. Right, when we have a fraction with two terms, we want to combine it to make a fraction with a common denominator. If you have a single fraction, you often want to split it into two fractions with the same denominator and work from there. A bit like with logs, splitting and separating. Right, so my common denominator is going to be 1 plus cos A multiplied by sine A. So left hand side. Okay, I've multiplied 1 plus cos A by sine A, so I do the same to the numerator. I multiplied the sine A by 1 plus cos A, so I do the same to the numerator. Okay, right, so let's do a bit of tidying on the numerator. So we've got sine squared A plus, and then we'd have, remember, you should probably write out the brackets if you're liable to forget. You get 3 terms from this. Okay, right, now, bit of magic. We have got sine squared A plus cos squared A, and we have the identity that those two add up to 1. So if we add that onto our 1 we've already got, we get 2 plus 2 cos A over sine A, 1 plus cos A. We can factorise that numerator, which is very handy, because then it will cancel with the denominator. And that leaves us, thankfully, with the right hand side.